today we are going to learn concepts based on circles, and then we are going to discuss some amazing problems based on it. So in circle, what do we know? That if center is O and the radius is R, then what we can say, that area of this circle will be equal to pi r square, and the circumference will be equal to 2 pi r. Of course, the diameter is 2r, and we can also write area and circumference in form of diameter. We just need to replace, instead of r, you can replace it by d by 2. Now let's come to other thing. If we talk about a sector in a circle, so this angle is theta, O, A and B. Can we say OA will be radius r, OB will be also radius r? What will be area of this circle? Sector, not circle, area of this sector of this circle OAB. We can say area of sector AOB is equal to, so theta upon 360 into pi r square. Now in this sector we also get segment. So this shaded region is known as segment. And how do we find area of this segment? So area of segment made by angle theta is equal to, we need to find area of this sector, which is pi r square theta upon 360 minus area of this triangle, which we can write half r square sine theta. Okay, so this is how we can find the area of sector and area of segment. Now let's try to learn more about circle. If I join any 2 points on the circumference of a circle, then this line segment is known as chord. What do we call it? AB is a chord, and the largest chord in any circle is the diameter of the circle, means that also passes through the center. Now the most important thing about a chord, that angle made by a chord in the same arc are always equal. Like if this angle is theta, this angle will also be theta, this angle will also be theta. All of these angles will be theta. Then there are one more similar concept, that angle made by a chord on the major arc is theta, then angle made by the same chord on the center will be 2 theta. Okay, this. And also you can say that angle made by this chord on the minor arc will be 180 degree minus theta. Okay, this is theta, then angle made by the same chord on the center will be 2 theta. Angle made by this chord AB on the minor arc will be 180 degree minus theta. So you can understand that if this angle is 180 degree minus theta, this angle theta should be between 0 to 90. Okay, and this angle will be obtuse angle. 180 degree minus theta will be obtuse angle. So if ever you see angle made by a chord on the circumference is obtuse, then angle made by same chord on the center will be 2 theta. If this is 180 minus theta, this will be 2 theta. If this is 120 degree, then this will be 60 degree, and so this will be 120 degree. If this is 110 degrees, so this will be 140 degrees. Why? Because this will be 70 degree. Okay, now more properties on chord. So let's draw 2 chord, chord AB and chord CD. And this is center O. Then what we can say, that if AB is greater than CD, then the perpendicular length drawn from center to these chords, this one and this one, let's say this is P and this is Q. So we can say OQ will be greater than OP, means the perpendicular length of these chords from the center will be in this relation. If chord is bigger, the perpendicular length from center will be smaller. जितना दूर जाएंगे कोड की लेंथ उतनी कम होती चली जाएगी. Okay. Now then comes intersection of chords. Now if we talk about intersection of two chords, something like this, chord AB and chord CD. Now let's say these two chords intersect at P. What we can say that AP into PB is equal to PC into PD. Okay. Now if these two chords are not intersecting inside the circle, something, let's say situation like this, that we have two chords which are not intersecting. This is AB and this is CD and this is point P. So these two chords are intersecting outside the circle, which is P. So what we can say again here that PA into PB will be equal to PC into PD. So this is the same relation. Okay, but in one case chords are intersecting inside the triangle, in other case chords are intersecting outside the triangle, and the intersection point is P. Now apart from this, also remember that if you draw a perpendicular to any chord from the center, it bisects the chord, means AP will be equal to PB if OP is perpendicular to AB, or vice versa is also true, that if OP is bisecting AB, then OP will also be perpendicular to AB. Now let's come to tangent. What is a tangent? From any point P, if we draw a line which just touch this circle like this, this is PA, then PA is known as tangent to this circle. Now properties of tangent with respect to circle, that if you join a radius to the point of contact of this tangent, then it will always be perpendicular to it. OA is the radius, A is the point of contact, OA will always be perpendicular to PA. Then again, if you draw another tangent from one point, you can draw two tangent and both of them will be of equal length, means PA will be equal to PB. The tangents drawn by same point on the same circle are always of equal length. Apart from this, there is another relation regarding tangents, and say this is PA, and let's draw a line which intersect this. So this point is P, B, and this point is C. What we can say, PC is known as secant. PC is known as secant of this circle, and we can say PA square will be equal to PB into PC. PA square will be equal to PB into PC. Okay. Apart from this, what else do we know about tangent? So let's take a chord something AD. Okay, then there must be some angle. This angle is theta. Then we can say that angle made by the same chord with the tangent is equal to angle made by this chord on the circumference, means this angle will also be theta. If this angle is theta, the angle made by AD with the tangent is angle theta, then angle made by chord AD on the circumference will also be theta. Now there are more concepts based on circles, but we will try to learn them from questions one by one and upcoming sessions. So it says what is the length in centimeter between two parallel chords of length 30 centimeter and 16 centimeter in a circle of radius 17 centimeter. So first let's draw a circle. Now we don't know that these two chords are on the same side of the center or opposite side of the center. So what we can say that let's take this chord and another chord. If we take first case where both the chords are on the same side, let's say this is AB and this is CD. Now if I draw a perpendicular length, so can we say something like this? So if I join OB, it's given that the radius OB is 17, AB is given which is 30. So can we say if this point is M and this point is N, MB, BM will be equal to 15, AM will also be 15. What we can say about the length of OM? Using Pythagoras theorem, can we say OM will be equal to 8 centimeter, right? OM will be equal to 8 centimeter. And then if I join OD, OD is also the radius, right, which is 17 centimeter. What will be the length of ND? So CD is equal to 16, ND will be equal to 8. Again OD is 17, ND is 8. Can we say ON will be equal to 15 centimeter? Now in that case, the length between these two chords AB and CD, right, AB and CD is nothing but MN, and we can say MN will be equal to 15 minus 8, which is equal to 7 centimeter. But if you check the options, there are two different possibilities, right? So what is that second possibility? Can we say that second possibility will be when one of the chord is on the other side, okay, of this given center. So in that case, let's draw it something like this. This is center O. Now if I join this one, I can also join this one, right? This radius is known, which is 17 and 17. This is AB, this is CD, this point let's say M, this point is N. So if I draw the perpendicular, it will bisect it, right, as discussed. So in that case, MB will be equal to 15, ND will be equal to 8. Then what will be the length of OM? OM will be equal to 8 and ON will be equal to 15 using the Pythagoras theorem. So in that case, the perpendicular distance between these two parallel lines CD and AB will be 8 plus 15, which is equal to 23 centimeters. And so our answer is option D. The distance between these two parallel lines is 7 centimeter or 23 centimeter. Next question, it says in the adjoining figure, chord ED is parallel to AC and AC is also the diameter, right? If angle CBE, this angle is 68 degrees, then what is the value of the angle DEC? We need to find the value of the angle DEC. We need to find this angle. So how do we find it? First of all, what do we know about diameter? That angle made by a diameter on the circumference is always 90 degree. This is center O and this is chord AB. Then angle made by the diameter on the circumference on either side, either arc, the angle is always 90 degree. So as it is mentioned in the question that AC is the diameter, somehow we should try to use that information, that angle made by AC on the circumference will be 90 degree, right? How do we use that? So first of all, I know that angle made by EC on the circumference, which is EB, is 68 degree. Now, do you see any other angle made by AC? So, no, there is not. But can I say, if I join this point, I have two things to consider. That angle made by AC, this angle will also be 68 degree, as well as angle made by the diameter AC will be 90 degree. So this angle will be 90 degree, not this angle. This angle AEC will be 90 degree, right? Now in that case, can we say this angle ACE? So angle 68 degree plus 90 degree is 158 degree. Now, can we say that this angle will be 22 degree, then only sum will be 180 degree, angle A plus angle C plus angle E. Now, it's given that AC is parallel to ED. So, corresponding angles should be equal, right? Can we say if this angle is 22, this angle will also be 22 degree. And so, our answer is option B. Alright. Now, let's go to the next question. It says, in the figure given below, which is not drawn to scale, A, B and C are 3 points on a circle with center O. The chord BA of length 8 root 3, BA is 8 root 3, is extended to a point T such that CT becomes a tangent, CT is a tangent to the circle at point C. Angle ATC is given, which is 20 degree. Angle ACT is given, which is 50 degree. Then the diameter of the given circle. Nice. We need to find the diameter of the given circle. How do we solve this? Can I say, in triangle ACT, this angle will be exterior angle, which is sum of two opposite interior angle. Can we say this angle will be 70 degree? If this angle is 70 degree and TC is the tangent, so angle made by the chord AC is 50 degree. This angle is 50 degree. Can we say angle made by this chord here? This will also be 50 degree. If this is 50 degree, angle made by a chord with the tangent is same as angle made by the chord on major arc. So if this is 50 degree, can we say 70 plus 50 is nothing but 120 degree. So remaining angle, this angle BCA will be 60 degree. And if this angle is 60 degree, can I say the angle made on the center must be double of it, which is 120 degree. Now think about this triangle OBA. In triangle OBA, we can say that this is radius R, this is also radius R, this is angle 120 degree, this angle AB is 8 root 3. These two angles must be 30 degree and equal. Can I say in 120, 30, 30 degree triangle, the property is, if this length is R, this length is R, this length must be R root 3. We can say R root 3 is equal to 8 root 3, or radius R is equal to 8 centimeter. What do we want? We want the diameter of the given circle. So diameter D will be equal to double of the radius, which is 16 centimeter. And so our answer is option C. Alright. Next question, it says, in the given figure, PA and PC are tangents to the circle. PA and PC are tangents to the circle. Angle ABC is given, which is 118 degree. Then angle APC is angle APC. This angle we need to find, right? So how do we find? So we had just discussed this, that the angle made by a chord, if this angle is 180 degree minus theta, then angle made by this chord will be 2 theta. Can we say 118 is equal to 180 minus 62, right? So angle made by this chord on the circumference will be equal to, means this angle will be double of 62, so this angle will be 124 degrees, right? This angle will be 124 degrees. Now if this is our center O, can we say OA will be the radius, and radius is perpendicular to the tangent on point of contact, so both of these angle will be 90 degree 90 degree. Now can we find angle APC? We can say angle APC should be equal to, now think about this, OAPC is a quadrilateral, this is 90 degree 90 degree 180 degree, this angle is 124 degrees. Can we say this angle plus this angle should be 180 degree? So x plus 124 is equal to 180, or x is equal to 56 degrees. So our answer is 56 degrees, that is option B. है ना? Another question, it says two mutually perpendicular chords AB and CD intersect at P. AP is 27, PB is 13 and CP is 9. Find the radius of the circle. So first of all we need to draw two chords, something like this, right? And it says AP plus PB is 13, so AP will be 40, right? Can we take this as AB? The intersection point is P, so AP, okay, I should take this as B because AP is bigger than PB, so let's take this as B, this as A, this will be 13, this will be 27, and then it says CP is 9, so CP is 9. Now we know that, what do we know, that whenever two chords are intersecting each other, we know that PC into PD is equal to PA into PB, right? So from there we can say PD will be equal to PA into PB, which is 13 into 27 divided by PC, which is 9. So 3 times this will be equal to 39. So PD is equal to 39. Now how do we solve this question? How do we find the radius of this circle? Now let's take the center O here. Okay, now if I take center O and draw a perpendicular to this chord as well as to this chord, now let's say these points are M and N. Can we say the whole length of AB is equal to 27 plus 30, which is equal to 40 centimeter? In that case MB, it will be half of it, which is 20 centimeter, and in that case MP will be equal to 7 centimeter, right? MP will be equal to 7 centimeter, AM will be equal to 20 centimeters as well. Apart from that, if we talk about this length CD will be equal to 39 plus 9, 48 centimeter. In that case CN will be equal to 24 centimeter, and in that case PN will be equal to 15 centimeter. So if PN is 15, let's join O and A. Now these two chords are perpendicular to each other, all these angles are 90 degree. Can we say PNOM must be a rectangle? In that case, if PN is 15, MO is also 15 and MA is equal to 20, can we say OA will be equal to square root of 15 square plus 20 square, which is equal to 25. You can also find this using Pythagoras theorem. OA is equal to 25, and that is your answer. So our answer is option A. But there is a but. What is that but? That you can find the radius directly. If these 4 lengths are given, then you can find the radius directly. Now let's say that in a circle, two chords are intersecting each other at 90 degree. This length is A, this length is B, this is C and this is D. Then we can say radius R is equal to A square plus B square plus c square plus d square upon 4. So you can directly use this next time onwards. Okay, now instead of ABCD you need to use 9, 39, 13 and 27, and you will get your answer as radius is equal to 25 centimeter. All right, so with that we are done with our first session on circles. I hope you enjoyed it and got to learn something. Thank you.